Bob Celeste, and this is Open Mic Friday. I hope you enjoy our talk today. We've just started these broadcasts where we invite interesting people to talk about their interesting lives and the things that they're doing. If you're on the live broadcast, there's a couple of things you can do to participate. You can raise your hand, and I'll try and get to you and get you unmuted so you could ask a question of our guest today. If you just want to type in a question, you can do that also. I'll try to do my best to channel you, and I may actually open up your mic also. If you go to our website and you go to Open Mic Friday, you'll see our upcoming shows, and you could also go to previous shows. So we're recording this. We'll put it up in the previous show area for you to listen to. If you're listening to this as a recording, you won't be able to raise your hand.
Would you show them, hi, it's Lynette Burns, everyone. Would you show them, please, where the previous recordings were under that listing? You couldn't see that on your screen. Thank you.
I'll go try and redo it. Let me see.
Okay, sorry.
I killed that one.
Oh, it's under, okay.
Okay, it's under Tune In, Open Mic Friday. And at the top of that screen, when that renders, you'll see previously on Open Mic Friday. And you could go in there and listen to a previous. And by the way, that was Lynette. Lynette will be tuning in on and off during the show today and answering, hopefully bringing in some questions. So without further ado, I'd like to introduce to you Dr. Swamy Narayanaswamy, and let me see if I can get this going here. And Swamy and we met. I'll just let you speak just for a second so they can hear your voice and understand that we're both here.
Hey, Bob. Hello, everyone. Good to be on this talk.
And Swamy, we've worked together now for, has it been 2 years? I think through the center.
So.
And you've been doing a lot of interesting work in the area of AI and machine learning, and we've been working together to try to use that to the advantage of some of the studies that we do and the information that's captured through those studies. And I thought it'd be interesting to have Swamy on today to talk to us about AI, machine learning, and tell us a few tales of projects that he's been on and things that he's been doing. And again, as you have questions as we go through this, raise your hand on the GoToWebinar area or just type in a question. So why don't we just start off? And Swamy, maybe just a little bit on what is AI and what is machine learning.
Yeah, I mean, you're starting off with the question that could take us days to answer, but let me try to summarize it as fast as possible. First of all, I mean, I want to avoid a whole bunch of technical talk, and people can always read about these things. What I wanted to cover is kind of the basics of what this is. I mean, first of all, you know, everything is there in the term. I mean, what do we know? What do we think of as intelligence, right? I mean, we say so-and-so is smart. What do we really mean? And when you try to break that down, you begin to realize that there can be different definitions of the word intelligence. And in fact, if you look at how different people in the field approach it, especially researchers, you know, some try to look at it from the perspective of the brain, and some people look at it from the perspective of software and so on. And given that, you know, we're in a very practical kind of context here, basically intelligence comes down to the ability to do a few things that resemble human capabilities. I just want to take you back a little bit to a gentleman called Alan Turing. Alan Turing, there was a famous movie about him called The Imitation Game. Very interesting person who was around during World War II, and arguably, yeah, go ahead.
The Enigma.
Yeah, exactly. And exactly, thank you for that. You're right. And basically, you know, he arguably saved Western civilization, you know, from the Axis nations, because he broke the Germans' code. And you know, part of what he did, right? I mean, the reason I'm mentioning it is that he was the first one to actually think about what it means to have smart programs, and the criteria he came up with still hold true today. So I'll just give you what these criteria are. The first is natural language processing. I mean, the way he says, well, part of the reason it's called imitation game is I want you to go into a little bit of a thought exercise, right? Imagine there is a barrier between you and an agent. You don't know whether the agent is a person or a program. Both of you have keyboards, imagine, and so you're typing on a keyboard and the agent types into a keyboard and you're able to see what the agent types. The agent is able to see what you type. And so Turing imagines, how would you think that the other side, you wouldn't know if they're a person or a program. And here are some of the things he talks about. First is natural language. If I have to talk to you in Java or Python, you're probably not a human being, right? I mean, that's pretty easy. So it has to be natural. I mean, just the way I'm talking to you, application should be able to talk to you as well. So that is a very key factor. The second thing he talks about is called knowledge representation. What that means is basically you want the program to be aware of the universe in which it resides. Think about a spreadsheet, extremely useful program, but it has no knowledge about the world in which it resides. In other words, you and I have to program the spreadsheet and its basic capabilities, which are pretty powerful, but they don't know what the columns mean. All that stuff comes from us. We interpret that, but the spreadsheet doesn't know, when it moves from an accounting application to some other application, that it is modeling a different part of the universe. That would be so valuable if the programs knew the universe in which they operate. That's called knowledge representation, and that really comes in handy. I mean, I don't want to have to tell you everything about the world in which you live. Most of us kind of know that automatically, right? As we live, intelligence means you know the universe in which you live, and I don't have to define everything for you from scratch, which right now for programs we have to do. So knowledge representation is a key thing. Logical reasoning. I mean, if there are some facts and you can deduce new things from those facts using logical principles, right? All of us have logical reasoning capability. If I had to tell you everything you knew and you couldn't deduce anything new from it, that would be a problem. I mean, so I would immediately guess, well, this is a piece of software because it forces me to tell it everything that it needs. Whereas a human being would converse more easily and they'd make some logical deductions and we'd feel comfortable with that interaction. So that's the third piece. And then the final piece is learning. Learning is basically, you think about children even, right? And those of us who have been both blessed and cursed with raising children, we know how they learn and the process by which they learn, and it is a marvel. The idea basically is that from seeing patterns of data, patterns of behavior, you're able to generalize and leverage it to do other, more important things, more powerful things. That's called learning in the human context, and this has evolved into its own field called machine learning that Bob referred to. Basically, those of us who come from the AI world for a very long time, 30, 35 years, right? We think of machine learning as a component of AI. But machine learning has become its own huge field now with its own technologies. It merges data science and computing and so forth. And so it's become a big field with a lot of activity going on. I can get into more details as we discuss more questions.
So is it not necessarily a subset of AI, or is it another aspect of it?
Historically, it is a subset of AI, but these days people, you can advance AI without being, without doing all the four that I talked about. I mean, you could have a machine learning application that is fantastically smart and is processing data, in a great way to achieve business results. And that is definitely an intelligent application. So you can think of machine learning as a component of AI, but it is now kind of evolved into itself. I mean, a lot of people do machine learning from the data science side. They come into machine learning. They may not think of themselves as doing AI, but they are. I mean, as far as we are concerned, we think of AI as the big circle and machine learning as a big component of it.
So back in the 80s, when I was telling you a little while ago, when we had the computers with floppy disk, I remember playing around with some AI software, and it never really did much of anything. So what's changed that now we see so much around AI machine learning?
Yeah, I mean, this is a very important question because, sometimes we can get kind of herded into thinking that something is more important than it is by good marketing. I think there is something going on with this field that we are at sort of a tipping point, to use Malcolm Gladwell's terminology, right? So what are the tipping point is when, if you have just one factor, then, the tipping point doesn't quite happen. But when you have multiple factors, then certainly, you see these tipping points essentially happen. And so what are these different enabling things that have caused this tipping point? Well, think about it like this. When you use your application, you use the word floppy disk. I don't think those things exist anymore. So that's kind of like, the universe of data that's available to an application like that is pretty small. These days, data is available on anything, right? I mean, so imagine if you're in the supply chain field, and let's say you want to make smart sourcing decisions based on market data, real fluctuations in the price of something. Can you see such data today? Of course. If your sourcing decision is weather dependent, can you see real-time weather data? Of course. If you want to project political conditions in a country from which you're sourcing something and you want to see, that kind of data, the data availability, data access is a huge factor. Computational power is another thing. I mean, so, think about how computing has evolved in just the last 30, 40 years where, something called Moore's law applies, right? Moore's law is basically for a long time, it's not true anymore, but so to speak. But basically, early in the cycle, every year or so, computing power would double, and it would also become cheaper. Now, that is revolutionary conditions. That's that tipping point kind of stuff. Now, why is that important? Well, think about it like this. It's the one field where you can procrastinate without any consequence, right? The computer's on sale for $1,000 and it has a certain speed, and you wait for another 6 months and you can get twice the speed at 3/4 of the price. That's amazing. So it's like computing power is now available in all kinds of ways, and some of the algorithms that go into machine learning and AI are computationally intensive, but they can run on available computing power. In the old days, we would need special machines with huge amounts of memory, and the cost was just exorbitant. So computing power being accessible is important. And finally, and this is one of the not so recognized parts of this, the market for all this stuff, the software market for this has really changed because of the open source, open source culture. What has happened is that all the big vendors, Amazon, Google, IBM, all of them have platforms that they offer for AI, for machine learning, and they want you to build your applications on their platform. But in the old days, they would just charge whatever they could and get away with it. I mean, or you would have to build your own stack. The availability of these open source libraries makes it so that you can easily experiment. You have the data, you have the computer to run it on, and you have these open source libraries, so you don't have to go hire an army of programmers to play with this. And so that, to me, is the tipping point, and that's why there's so much interest in all this stuff.
So if you're trying to use AI or machine learning, are you pointing it toward sources of data, or are there times where to your point about where we're so connected now, you can almost tap yourself into almost any source of data? Do they also go out and look for things that might be interesting on their own?
Yeah, most of the high quality AI and machine learning applications start with good data, and good data is hard to find in the wild. I mean, so, it's usually you have some awareness of where the good data is. So, I mean, I mentioned to you, for instance, weather. So you have to know what's a good source of weather data. You might find different, sources available, and you have to curate them and make sure they're of high quality. There is a whole branch of AI that's looking at discovery of, good information. But that happens at it's on a whole another scale. I mean, if you're looking for enterprise robustness and quality of data, you have to start with good data sources. So I think the discovery tools are not quite there where you can just automatically expect them to identify, great resources that will immediately make an impact in your enterprise. You'll have to do a lot of cleanup of that data and curate it.
Okay. So I saw something recently. A good friend of ours, Jim Sabagal from T Systems, he posted on LinkedIn an example where I think it was a Google AI thing was trying to help surgeons or researchers to identify cancer in slides and other scans of people. And one of the things that they, obviously it was faster. So I think that's pretty expected, that a computer would be faster at identifying things that it could calculate. But the other thing I thought was interesting was that it was finding cancers that no one else was finding. And maybe you could explain this part. Because of the AI, the way it works, they couldn't figure out how the AI was making the associations. And so their next project almost is to I guess, interrogate the AI to figure out how it's making these connections and finding this cancer.
Yeah, I mean, you've raised a very interesting example, which I thought, I'll use this as context to kind of introduce a few more simple concepts. Let's talk about machine learning. It comes in two basic flavors. One is called supervised learning, and the other is called unsupervised learning. Supervised learning is the most common type of application of machine learning you see out in business practice today. And supervised learning essentially says that you've got, I'll give you an example. So imagine that you've got a good team of supply chain sourcing people on your staff, and they've made a bunch of sourcing decisions. What you could do is characterize, supposing I told you, write a program that emulates what these human sources are doing, so you can use their smarts. It's an extremely tough algorithm for you to create. But what you could try to do instead is let me really figure out what choices they made under different conditions. So you could identify all the key criteria for making a sourcing decision. Could be, is the price point, the location, how flexible are they on price? What's the financial situation of the supplier? Which country are they in? Are they flexible on, delivery modes and things like that? So you could characterize that and then see what sourcing decisions the experts made in the past for those conditions. And then the machine learning algorithm essentially generalizes from that, finds the patterns, and finds a way to predict what the sourcing decision should be. Which supplier would you select for some new set of criteria that is not there in the old set? The old set is called the training set, and you train the machine learning model using the past data so that for new data, it can predict the output. So that's called supervised learning. And unsupervised learning, as you can imagine, there is no set of previous training examples. All you have is a big body of data, and you're trying to make sense of it. The case that you mentioned is something new called neural networks. Basically, it's called deep learning. And so the example that you talked about, this thing basically uses a small set of, a huge set of examples, and it can generalize and kind of model human thinking to come up with some conclusions that a human being would not be able to come up with. So in this case, you can imagine that the neural network essentially looks at the MRIs, for instance, and knowing what you're looking for, it is able to find things that the human perception, the human eye is not able to pick up. I don't know if you've ever seen MRIs, I don't know how people make anything of it, So it's actually easier for computers to not be fooled by certain things that you see visually. So neural networks and deep learning, as they call it, is a huge area that has emerged, I would say, in the last 4 or 5 years. And many problems are getting solved in different ways. It's just an interesting point for those interested in games and so on. If you know about the game Go is very similar to chess, and it is much more complicated because it is a 19 by 19 grid with all equal pieces and a huge game of strategy. And so to your point, the way chess playing programs have used artificial intelligence to beat human beings, is really brute force. If a human being can think about a grandmaster can look 5 moves or 10 moves ahead in a chess game, basically through brute force, these algorithms can look 15 moves ahead, and they were able to beat human beings. In Go, this was not possible. Human beings were using very different strategies to beat a computer until recently. AlphaGo, which is again based on neural networks, to your point about the MRIs, exactly the same sort of technology. AlphaGo, the program from Google, finally beat human beings fairly consistently. And it was doing so by using strategies very similar to human beings that human beings had not seen before. So that gets into the neural network is starting to behave like a brain. You can think of supervised learning as essentially giving you results that a human being would give you, but neural networks begin to think like human beings. That's a different thing. Delivering results that a human being would deliver is different from thinking like a human being, if you know what I'm saying.
So this is kind of interesting space that we're in now. How do you actually use this, or what would this mean to be able to use this in a real world application, such as supply chain or anything kind of pedestrian other than looking for cancers and things like that?
Yeah, I hope you're not looking for cancers in the supply chain data, but yeah, you're absolutely right. Supply chain is no different than any other data-driven situation. I mean, supply chain has data running through it. It's kind of the lifeblood of the whole supply chain in a sense. And so I think it's useful to think in terms of what are the applications you could run. And you could look at all the different components of AI that I talked about before, right? Starting with natural language, for instance. The easiest way you could think of incorporating AI into the supply chain is you imagine that there's people working on the loading deck with your supply chain materials, or there could be someone on an oil rig somewhere confused about a part or not sure whether something is available and so forth, right? And I'm thinking of these guys in gloves with very greasy situation, and they're trying to type something into a tablet. How about a natural language interface there, so they can just say what tell me about this part, and have this thing talk to them, so that the natural language interface becomes a key driver in those types of things. So this is the kind of thing we think of as augmentation. So take your process and augment it with natural language interactions where it has high value. You can think of smart sourcing. I'd mentioned this before. So wherever you're buying things, now you have all the data that you could think of, very up-to-date market data, movement in international currencies, weather data, political data projected into the future to see where the stable things are. If logistical, logistics algorithms and routing and things like that make a difference, you could be paying attention to that. You had mentioned IoT. This is a very key point. If I have sensor data that gives me information about where my goods are, if not all the time, periodically, etc., that changes. It opens up a whole new vista of applications in things like location-based search, custody of key products, theft. And in our projects with you, as you know, we've been working on this thing called cold chain, where the temperature sensors in the product, like temperature sensitive products like pharma products or food products, if I'm able to tell what they're, what's going on with their temperature minute to minute, I might be able to do different things. I mean, there are inventory control, warehouse management, all of these things have real-time data in them. There could be predictive elements. And so, just a matter of where in the value chain you feel like intervening, where you think the high value, low cost use cases are, and focusing your energy there so that you can start getting some validation that your approach is working.
So you mentioned augmentation as a way of kind of bringing this technology alongside us as we do our work from day to day. And when I think about that, I think how helpful sometimes, but also still very cumbersome, something like Siri is, where I ask Siri a question and most of the time she tells me she doesn't understand what I'm talking about, or she'll come up with something very strange. You have to be careful what you ask her sometimes. Yeah, there's enough of those recordings on YouTube.
Yes, I think that you make a valid point. I mean, Siri is a you have to think of it as that kind of technology, but applied in a narrow domain. One of the problems with Siri is, right, all of us forget just how much knowledge, common sense knowledge, we all carry in our heads, right? Somebody once told me that forgetting is a very, very key human talent. I mean, if you can't forget, you'll go nuts. And because there's so much irrelevant data, common sense data that we all carry in our heads, right? Siri has difficulty because it works in the hardest of all domains, which is common sense reasoning, because it has to know so many different things. I don't know if any of you watched IBM Watson in action with the Jeopardy players a few years ago. The amazing thing was that IBM Watson managed to beat the Jeopardy players, and the amazing thing there was, it's Jeopardy is a common sense game. It's general knowledge, but it's situated in the real world. So if I say something like the prince who got wet in the purple rain, you have to know that I'm not talking about a kingly prince. I'm talking about the singer prince who wrote the song Purple Rain. And these are the kinds of questions that that require common sense knowledge. So Siri is in a tough spot. However, you could take the voice technology and apply it in a narrow domain where, by simply, remember, human beings learn very fast. So if by saying, show me the part, I'm able to see the part, and I'm able to read the serial number to it instead of having to scan it when I can't scan it, those kind of things. I mean, I think about a narrow domain, but a very powerful technology working in that domain so that you can make more progress than Siri can.
So they understand, they start to understand context that you're speaking in, and
Yeah, those are the customizations you have to make. So when you bring in a voice technology, that's pretty generic. So now you have to show it what your domain concepts are. You have to show it, how to articulate different things. You have to train it to be good in your domain, and then you're good to go.
Good. I'm gonna bring in Jim, who we mentioned before. He had an interesting question. I'll see if we can get the technology working here. Hey, Jim.
Yeah. Thanks, Swamy. So I think very interesting points. So one of the things that I think we would want to see from the technology is the ability for it to give advice to the user. So the idea, and you mentioned IoT, of course, that's my interest, where I'm presenting the data, and then all of a sudden now we start learning about, what constitutes an error, and how much of that advice do you provide back to the user? Because certainly we're not making any changes. We're just saying, okay, something's wrong, and these are the reasons why. And then based on that, is it that we advise machine learning and AI to kind of make the changes, or is it something that it's going to learn? First shipment comes through, it's bad. Second shipment comes through, it redefines what that problem is, that kind of thing. How much of a constraint do we have to give to it? Or feedback, I should say, not constraint. Do we have to give to it? Does that make sense?
Yeah, I think so. Good question. I think this leads to an overall area of, how do you use these technologies? I mean, I've kind of been talking up the capabilities of the technology, but let's look at limitations and pitfalls or potential issues that you have to look at, as you need to with any business application, right? First thing, let me ask you, supposing I recommend something to you, I'd say, put all your life savings on a particular stock. What causes you to believe me or not believe me? I mean, Jim Cramer jumps up and down and says, buy this stock. Do we do it right away? Or, do we wait? How do we establish trust in something is a very, very critical issue here. And most of the time what we are doing is, right, we either trust the source, they've been right before, et cetera, et cetera. So I would say, to go to your point, for the foreseeable future, I think all this stuff has to be watched carefully, and you have to monitor its performance by having a human being look at the performance, curate it. If not, every decision you have to do enough to where if the thing is going nuts and going off the rails, you know about it. So I wouldn't just go out and make the changes that it recommends. I think that most companies would, especially in mission critical situations, have some curation of the result. I mean, if we're talking about managing the marketing budget for a company using AI, right, and the net result is you blow up your marketing budget on something that doesn't work out, it's not the end of the world. But we are talking mission critical decisions, diagnosis of something. Yeah. Those things I would apply basically good business practice and watch this thing. And over a period of time, we begin to trust it. Right now, nobody questions Google's results. But you might remember a time when Google was playing alongside Alta Vista and Yahoo and all that, and those engines were better. But nowadays, nobody uses those engines because we all trust Google. But the Google trust had to be earned. You can't just give trust, it has to be earned. And so what that means is rationally, you have to test to make sure that the conclusions work and work all the time, or most of the time, 90% of the time, have those metrics handy before you start making changes automatically. That would be my recommendation.
Okay. So Swamy, is there a situation where if the AI engine or whoever gives you advice that you'd be able to interrogate it as to why it's giving you that advice, and not really getting back a dump of data? That's not real helpful, but kind of the same thing you go through with a person.
Exactly. I mean, in fact, this is one of the key areas, and this is not a solved problem, by the way. You're getting into an area where the practical limitations of some technology like machine learning, right? You can throw a mountain of data at it, have some fantastic math models, and I always tell people that expect me advice from me. I say the math always works. You throw any kind of data at it, the math will crunch it, and at the end of it, you'll have a conclusion with some probability. For instance, how do you, how do you believe that? And the reason you would believe it is what you just talked about, which is called explaining. You have to explain your decision. What did you do to come up with the result? You might remember math classes, right? In your high school or whatever, if you just have the right answer, they won't give you the credit. You have to show your work. Mm-hmm. What showing your work does is it convinces somebody else that, hey, these are the steps I went through to get to my answer. And so this is exactly the same sort of thing. We have to have systems that are capable of, right now we think of explanation as a dashboard. You think of a nice chart, okay, that is part of the explanation, but really we gain trust in the recommendation or the conclusion by being able to see what are the calculations, what happens when I change certain parameters in the machine learning model. I mean, the basic machine learning model, because all these libraries are available, they're pretty easy to get into. Where the real skill and where you get real results is if the math meets the domain, and there are good people who have come from the domain, good people on the data science and machine learning side, they have to sit down together and figure out how do we make this thing more explainable so the business person begins to see the relevance of it, not just charts, but an actual explanation of what the different parameters mean. If I change this, I'm moving. I mean, so imagine in the sourcing problem, right? I might say, well, if you change this dial in the dashboard, you're changing the risk factor. And then they can see how the recommendation changes when they change their different preferences. And that begins to give them confidence, because now it matches their intuition about how the human being is doing things. Think about how human beings convince each other in a conference room. Similar some sort of process like that needs to happen, because why we believe one person over another is a very deep issue. Sometimes the person who has the best story is going to win. And so, it's not enough to have a bunch of data there. You have to have a good explanation of, why you came up with that answer.
And in fact, I will come back to this explaining thing, because it sounds like a big area of exploration, but I do have a book called Whoever Tells the Best Story Wins. And it goes through how all the numbers say people should make this decision, but they make a different decision based on more social cues.
Yep, no, it's very true. I mean, I'm sure all of us who have been in business for a while know the lonely feeling of being the only person in the conference room with the right answer, but not finding the right words to convince anybody else.
Right. I just want to bring someone in. Denise has a question and involves blockchain. Hi, Denise.
Hey, Dr. Narayanaswamy, hello, good afternoon.
Swamy, please. Just call me Swamy.
All right, Swamy. So my question is sort of getting back to last week's and now this week's. I want to kind of meld them together. What do you think, what are your thoughts about if you were to capture, identify an asset using like Google neural networks, and then you were to use that identification and put it on a blockchain, right? Mm-hmm. What are the challenges in your perspective in doing that?
Yeah, I think there are different set of challenges there. I mean, I think, the blockchain technology can play a useful role in provenance of decision making, and we were just talking about trust. And so, the fact that the data that supports a particular decision was certified and can't be changed is a very key component. The part that worries me about blockchain stuff is, there are walls. It's tough enough to make an AI algorithm work when all the data is available. Or a machine learning algorithm work when all the data is available, everything is there for everybody to see and so forth, and the algorithms can dig as much as they want. And so one of the key things that we have to think about is, what kind of use cases blockchain can support. It's very clear that it's a good security additive, but whether it's, rich enough to support the full set of analytics requirements and the full set of AI and machine learning requirements, I think that remains to be established. I think, that technology, people have to think of new mechanisms where they can have the cake and eat it too, have their security, but still be able to support the kind of applications you're talking about. So I think there is a way to do it, but I think work is needed there.
Okay, thank you.
Swamy, I have another question for you from, let's see, who's up here? Venkat. Let me just open up your mic, Venkat. Let me find you in here in the list. There you are. Venkat?
Hi, Swamy.
Venkat, how are you?
Good. Very similar question, actually. Blockchain, I'm seeing a lot of applications for blockchain in supply chain, for example, pharmaceutical, track and trace. I think last week there was a session in seafood. Unfortunately, I missed that. But could you please talk a little bit about, you might have touched upon it, but how does IoT and, we talked a little bit about location data, sensor data, the interaction between, basically the crux of my question is, can blockchain work? Is there enough data today in the supply chain for blockchain to be powerful enough, or do we need the IoT backbone infrastructure to provide that additional data set for blockchain to be effective?
Yeah, I think there are multiple questions buried in there. I mean, the way I would say it is, take out the blockchain for a second, right? I mean, because that to me is a kind of an independent technology that provides a very different set of benefits. If you're just looking at data availability, data access, and a way to pull all the data you have together to make smarter decisions of anywhere in the value chain, supply chain, wherever you think you want to focus, that's definitely doable with the available technology. Now add in blockchain. What blockchain does to me is, because of the security imperative, certain things are, especially when it crosses between boundaries. Think about one organization to another. Certain things may not be visible that we need to make visible, and there may need to be other arrangements that are outside the blockchain to open up those, the pieces of data so that there can be more of an end-to-end reasoning process and so on. So I kind of look at blockchain as an independent, aspect of the whole thing. So when you introduce security, you're introducing a few walls. You're getting some advantages, which is, the fact that the data is reliable and certified to be to never have changed, which is an important and critical property. What I'm not yet certain about is whether that technology has, whether there are good examples of that technology already well integrated into kind of an open data environment where reasoning and getting to the best conclusion possible by having all the data available, whether those two are fully compatible. That, I think, has not yet been established in the market.
Thank you.
Interesting. And Dheeraj had some interesting thoughts around how to go about implementing, is there a model for that? Dheeraj, are you on?
Yep, I'm on.
There he goes.
Yeah, it's very interesting. Thank you, Dr. Swamy. We are wondering how, not wondering actually, it would be more of an approach given the plethora of data that's out there with the ERPs and logistics and 3PL companies out there. What would your thought process be in adopting AI to supply chain? Do we churn ERP data? Do we churn any logistic companies data and all? How would somebody want to approach in beginning an AI project for their supply chain customers?
Yeah, I mean, I can give you, I think the ultimate answer has to be determined by people in the company. As a technology guy, I kind of know what approach I would use to do any exploration of AI or machine learning in a complex environment. A running business that has pain points, is not perfect, but is actually functioning at some level. There are risks in just doing things. And so I can tell you what that approach is. But I think you have to start from the business side of what are the key pain points. Find a key pain point where it's a no-brainer to go, look, we're leaving money on the table by not processing this data. It might be ERP data. It might be some data that's available on the internet. Keep it small for the initial scope. Like a proof of concept where, by habit and by culture, your company starts getting accustomed to the fact that just because it's called artificial intelligence doesn't mean it's going to solve all your problems, and it doesn't mean it's so hard that nobody can do it. You're at a point where you can easily think of let's say 10 different use cases, identify the data sources in each case, which ones are the least risky for you to start playing with. I mean, you can play with internet data without any problem. Some internal data, someone may look at you and go, well, what are you going to do with it? Or, there are these problems or those problems. So you have to analyze what are the important use cases, which data sources they touch upon, what are the risks involved. Keep it as small in scope as possible and learn from the experience. Just focus on one small thing, which is a no-brainer. Come up with clear metrics for if we can move the needle from here to here. I mean, I'll just give you a simple metaphor, right? We are in the needle moving business. No, AI and machine learning will not make all our problems go away, but we can move the needle from one place in business outcomes to a better place in business outcomes. So try to find one place where everybody in the team can agree. If we touch this data, it's not a big deal. It won't cause a whole lot of ruckus, and we can try to move the needle in the positive direction. Start with a simple POC. And as I mentioned, for the reasons that I said before, cost is not a big factor these days. It is actually quite affordable because computing wise, you can do it on a PC. You've got libraries that give you access to this stuff. Of course, you have to learn it. I'm not going to make believe that everything is trivial. You know, one of the key learning points is that if you have an army of programmers or a bunch of people on the data science side, you know, all of them have to learn certain technologies, you know, and that is always a painful process, you know, so there's no easy way to get out of that. But, you know, you can learn that. I mean, so the point is get going, because I think this is a good time for everybody to get into this technology and start learning.
Interesting. I think Dennis has a question that'll lead us back into the whole exploration of how to explain the answers. Hey, Dennis?
Mm-hmm.
Dennis, are you up or on? Well, I'll tell you what he wrote here, and maybe it'll provoke someone. No, I can't hear Dennis. So he's saying that the current state of neural networks is such that the system is not able to explain in its decision, and the programmers also don't know how it arrives at its decision. I think that's like to the point I was made before about that they couldn't figure out why this application was finding the cancers, and their next project was going to be, so how do we interrogate this artificial intelligence, if you will, to kind of dive into what it was putting together in the data.
Absolutely. You know, this is the crux of the AI machine learning dilemma that everybody should think about. You know, when I mentioned the areas of success, right? I noticed I selected problems where there is an obvious outcome to decide whether you won or not. Go. There is a configuration of the game where you can declare one party the winner. Jeopardy. You answer the question, so you know the answer is either you got it or you didn't get it. That's not the way business problems are. Business problems are such that you come up with a recommendation. If I say to you, my recommendation is that you go with supplier X and the probability is 0.6, what the heck does that mean? Should you select that person? Should you select them and not worry about it? Do you believe this thing? And so on. And the neural networks are highly mathematical. They're very abstract. And one of the problems they have is that the parameters and stuff sometimes are not intuitively obvious what they are. And I think this is where homework needs to happen. I mean, you know, when I talked about the availability of libraries, that's the math part. Connecting the business requirements to the math is something that human beings still have to do. And if you've got a good data science person and a good machine learning person, good programmers, you have a shot. And so, you know, we should not underestimate the difficulty of doing this, because, you know, the abstract parameters in some machine learning model, and particularly neural networks, which are highly, as I said, mathematical, they work, but, you know, what does that mean? You know, are these parameters intuitively obvious to the business decision makers so that they know that this is what the conclusion means, this is how they can monitor it? If I change this parameter, I'm changing something in my business, right? It has to correspond to something that applies in my business.
Interesting. So if you two things. One is maybe you can talk about a project that you've worked through and what you look at and the kind of questions you ask before you know. I guess AI and machine learning is a lot like blockchain, right? Someone shouts down the hall, "Where's our AI or machine learning project?"
Mm-hmm.
And you may get called in and have to kind of sift your way through things to understand whether this should be a project or not. And then also, if you maybe can you speak a little bit to kind of cost feasibility of these kind of projects?
Yeah, I mean, I'll share with you a couple of different projects we've done. One was a more recent one was for a healthcare kind of company. They were a little confused about, you know, they thought of themselves as a machine learning or AI startup, but they didn't know, you know, what the strategy ought to be. And so, you know, it came down to, I think somebody asked the question, how do we get going, right? Very similar to the problems that this healthcare company was having. And so we sat down and, you know, listed all their pain points, you know, where are the areas, and everybody was allowed to say whatever they felt, you know, where they feel they're overexposing the company, meaning risk, or where they're leaving money on the table, or where they could be more efficient, or where they could get more customers, or whatever it is. all the different use cases. We sorted through them. We decided, okay, this is the point of it. And then basically the way that I worked with that company and our team worked with them is to basically get their requirements and build a POC out of that requirement. So we focused on one requirement that said, document processing was difficult. So we started from, scanned PDF documents and end to end kind of showed them, okay, from the PDF, this is how you get to, kind of the text representation of it. Then we run some neural network algorithms to classify them. So that a certain form is certain document is a doctor's visit, and another form is a prescription, and another one is a, for hospital visit, etc. Whatever the different, like a pharma result, etc. Pharma, a test result, etc. So these are the types of projects that we did where going end to end, right? Again, we start with this POC concept. It's always about the POC, so that at the end of it, we had decided what the metrics would be, because they knew how long they spent doing this in their company, and by showing that, okay, we're able to save this much time, they were able to be convinced of it. We did it on a small scale. They were going to transition it off into the bigger scale. So I'm monitoring them carefully to see how they do that. But that's the kind of experience we have. We have some supply chain experience as well. We worked with a boutique supply chain strategy company. And so that gentleman teaches a specific process for managing strategies between the big companies that buy things and the suppliers who work with them. And instead of beating each other up about price, he had this very interesting strategic way in which they could both manage costs together. But those agreements were always based on assumptions about the real world, about conditions outside the agreement. And so there were often misunderstandings would arise because those conditions have changed, but the agreement stays static, and so people would start, hurling things at each other. So what we were able to do is to show them, well, look, let's keep all these assumptions around as actual data constraints that we are monitoring. And so you could come up with a live agreement that changes based on the conditions in the ground. And so both parties are happy because they've negotiated something that is data dependent. So we were able to keep their strategic arrangement going at a tactical level based on the data. So we would measure the data that would feed into the algorithm, and then we would decide the negotiated price based on that, so that neither party felt like they had locked themselves into a strategic arrangement that made no sense. Those are the kinds of projects we've done.
And I think we might have Dennis's, let me see if I can Dennis.
Yes. Hi, Swamy. Yeah, a fun seminar. Yeah, I read a little bit, not very much, about neural net learning. I don't understand deeply the neural networks, but all this new AI stuff is based on pattern recognition, basically, where you provide patterns, sequences of patterns, and give it a score as to whether it's right or wrong when it's identifying things in those patterns. So that's sort of the overall model. And the neural network reconfigures itself until it works better, until it works even better than people for many cases. And the inventors of it actually don't understand why it works completely. So therefore there is no concept of it explaining how it comes to its conclusion. So I clicked on a link. That was my understanding anyway. So I clicked on Google just now, and I found an MIT Technology Review article entitled "The Dark Secret of the Heart of AI," and it discusses this phenomena. And of course, it is interesting for the reason Swamy mentioned, that if you can't get an explanation, then how could you trust it, other than seeing that in fact it works, and works very well. So it's an interesting it's an interesting dilemma.
I mean, there is a whole I don't know how many of you know about an agency called DARPA, Defense Advanced Research Projects Agency. Most of the things we use today as regular things like the internet or GPS all came out of DARPA sponsored research many years ago. They have a new program called Explainable AI. So this is not something trivial. I mean, finding systems that can explain what they are doing is a pretty deep thing, because I mean it requires a level of intelligence, so to speak, right? I mean, you notice that even human beings, sometimes there are people who can solve problems, but they don't know how to explain how they do it. I mean, it's kind of like having Michael Jordan for a coach sometimes, right? I mean, it's like Michael Jordan is able to do things, but he's not a very good coach because to him it comes naturally. So this is an important issue that I think is being tackled in the field. To go directly to Dennis's point, I think right now the neural network stuff, if you need explanations, right, it's going to be tough because it's so highly mathematical and abstract that that part doesn't quite work. In fact, many machine learning solutions are inadequate in this regard. That's why I said you have to kind of check to see whether the conclusions work in practical terms. Neural networks is really good. For instance, think about the example Bob mentioned, where by looking at the neural network, people were able to find cancers that they had not found in MRIs. Now, how did they know that? Well, they went and checked the conclusion of the MRI and found that it was right and they were wrong. Now that introduces trust. They don't fully understand what it did, but if you do it 100 times in a row, it's kind of like a magic trick, right? You don't fully understand the mechanism by which the person pulled it off, but you will go, wow, it works. And that's kind of the ultimate test. So if there's a clear way to establish whether something works, you should use that methodology to always monitor how machine learning is doing. This is true for all machine learning algorithms. As of today, you cannot put your trust 100% in any of them. And the only way you will develop that trust and you'll start just believing everything it does is in maybe 10, 20 years, when all of us have that experience base, we're counting on these technologies and they're coming through for us over and over again, then you can trust them. But right now, for your mission critical applications, trust but verify. That's what I would say.
Can I add a couple points, Bob? Swamy?
Sure.
Yeah, so is there a way to share a link with the webinar audience?
Let me see. Maybe if you put it in,
go ahead.
yeah, I could share it afterwards, or you could try to put it into the questions area. I might be able to send it to everybody.
Yeah, I did in my question. I already included the link.
Oh, okay. Bob,
Gotcha.
can you share the screen with him?
Well, if you don't have to go to that trouble. Well,
Oh, okay, okay.
I'll share it out with folks.
Because then people would have to manually enter it. It's better that Bob just sends it out later.
Yeah.
Okay, it's a very interesting article, which goes to the points Swamy raised. And just to put a hammer down on this, if a person looks out in a field and sees a horse there, and you ask them, explain how you know that's a horse, good luck.
Yeah,
Same thing
this is true of so many things. I mean,
Yeah.
if you ask, everybody should do this experiment, right? I mean, try saying to Siri, well, what is the circumference of a circle with radius 2, and see what she says, and then ask her, how do you know that? It'll be interesting to see. I mean, I think explanation is where it is. Most of the time, right, we believe things because of the brand. That's what it is. I mean, we don't have the time to verify everything, but this is a huge area. I think, particularly for business applications, I think where huge money is involved, life and limb is involved, etc. I would say if it's mission critical, make sure that there's something in the loop that's monitoring the decision making of the machine learning algorithm. I'm not saying don't use it. I'm just saying use it as one additional source of information as you make the key decisions that you have.
Yeah, I mean,
to your point.
Yeah, if you want to go to the even further, I mean, Hinton, who invented neural net technology back in the 80s, which has now become feasible purely because computers are faster, himself says he does not believe this is the way humans' brains work, and this is not really AI, and we, quote, need to start over, unquote. so you can look him up, get his opinion on that. But it is very good at pattern recognition models where you're looking for a pattern and there's a success or failure criteria, and there can be trained. That's what it's good at.
Yeah, no, that's fair. I mean, I think there is a certain amount of this where, once these terms migrate into marketing intelligence and machine learning and stuff, they get overused and we imagine they are things they are not. So neural networks, from the beginning, people have said it models brain thinking and so forth. I think that's a little overblown, but it has value. I mean, like you said, it's basically pattern recognition by another means, very mathematical, highly abstract means. And Explanation is a key problem for all these technologies.
Yeah, it models an aspect of human reasoning, which is the recognition part. What it doesn't do is, for example, it could not do a mathematical proof that you go through a chain of reasoning that it uses to explain how it got to its conclusion. That's not what a neural network does.
Yep, I understand.
And I'm guessing that it could help also with us being, if you will, pattern blinded, where we may be looking at things and just not seeing it.
Absolutely. Yeah, there was a case where some documents were ingested. I worked at Cedars-Sinai for a while, and they were importing data from a new hospital they had acquired, and they used some AI technology to detect patterns in certain forms to find out if they were certain features, and the AI actually did a better job of helping them process that incoming forms than the people were able to do. So it detected new forms of anomalies, and so it definitely has wide applications.
Yeah,
Okay.
I mean, I kind of think of it as AI is seated at the conference table along with my smartest people, and AI is recommending things, and my smartest people are recommending things and questioning each other, and we go with the best conclusion we can come up with. I just look at it as yet another source of intelligent recommendations. That's the way I see it.
Great. Well, Swamy, we're heading up to the top of our hour here. Do you have any sort of final thoughts? We're going to have a second shot at you next week. I'll tell the folks about that in a second.
Yeah, I think that, you know, I've said pretty much everything I need to say, particularly the POC stuff I want to stress. I mean, you know, I'll just end with the short version of a story, which basically, you know, there's this martial arts master who's up in the hills, and somebody's learning from them, you know, like this muscle-bound young fellow is learning all the martial arts from the master. And so they go through this process. I'll again, the short version. So, you know, he goes through this apprenticeship, and finally he graduates. And so this little master who knows martial arts and this muscle-bound youngster, they go into the city, and 8 different thugs, you know, show up and want to get their money. And so the young martial arts guy immediately is in fighting posture and so forth. And then he's looking for his master to back him up, and the master turns around and starts running away. And so this guy is confused, but you know, he's trained to follow whatever the master does. So he starts running with his master, and they get away from the 8 thugs. And then he turns around to his master and goes, "What the hell? You know, you made me sit with you for all these years to learn these skills, and now you ran away." And the guy says, "Well, there's a difference." And he said, "What's the difference?" He said, "I ran away with confidence." So what that means, great. I'm saying basically, right, this is a good time for you to start learning everything about AI and machine learning. The right business decision may be for you to run away, but if you run away with confidence. Don't run away because you didn't learn about it. That would be my good takeaway message. That's
great. Well, I really appreciate you being with us today and sharing your thoughts. For everyone else, next week, you'll like I said, you'll get a second shot at Dr. Swamy. The Center's blockchain for cold chain team will be on the call, and we'll be talking about what we've been doing all year and the things we've been thinking about and how we've looked at different aspects of cold chain and blockchain and analytics. And so Swamy's part of that team, so you'll hear a familiar voice next week.
Well, I appreciate the opportunity to talk to this great audience. Thank you all for the great questions and paying attention. Everybody take care.
Great. And once we do a little editing on the call, we'll put it up in our previously on Open Mic Friday. You could get to it on the website. And everybody have a great week.